Welcome to 20.3. What are the major pollution problems affecting groundwater and other drinking water sources? Okay, groundwater threats. In the U.S., 50% of drinking water comes from groundwater. 95% of rural populations get drinking water from groundwater. Groundwater provides 70% of drinking water in China. 90% of aquifers near Chinese cities are polluted or overexploited. Industrial waste ponds, 33% don't have a liner to prevent leakage. We're talking about a big, thick rubber liner that goes underneath any type of holding pond for industrial chemical waste, right? There's got to be a thick rubber lining and then a clay lining underneath. So if any drips through or makes it through the rubber lining, right, then it still can't get through the impermeable clay layer, okay? 16% though, and this is in the United States, 16% don't have a liner, and they're located within 1 mile of a local area's drinking water well. That's insane. Groundwater cannot cleanse very well. Why? Okay, so pollutant is spread through porous rocks and cannot be removed. It's different than removing oil from, say, the surface of the ocean, right? We can't get into this ground and remove it from these little teeny tiny pore spaces. Slow flow rate. Groundwater moves maybe 3 feet per year, and that's on the fast end. Water that gets into the ground from the Appalachian Mountains and flows all the way to the Floridan aquifer, right, will take 10,000 years to do that. So you're talking about from Tennessee to Florida, underground, 10,000 years. Low dissolved oxygen. So this stuff is underground. There's no plants making oxygen. There's no wave action from the wind creating or helping to dissolve oxygen. So no oxygen. It's going to be very hard to break down this waste, if it's even biodegradable. And it's colder down there, so just like in any reaction, the colder it is, the slower it becomes. If you want to speed up a reaction, you got to add heat, and no heat is being added here. Groundwater threats. Okay, so leaking from underground fuel tanks. We use metal fuel tanks traditionally to hold the gasoline that you go to the gas station to purchase, and they have a certain life. You put something in the ground, Mother Nature is always going to try and take it back. So over the course of 60 years, which is supposed to be the life of these tanks, they get eroded, they rust out, and they form holes. And every time they fill them up to put gas in there, it's dripping out. Okay, MTBE, methyl tertiary butyl ether. So once they took lead out of gasoline, lead did a couple things. It was an oxygenator, right? It helped boost the octane level of the fuel to meet certain codes and help cut down on the knocking in the engines, right? Which was, an annoying sound, dot, 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 dot. So it helped make that stop. Well, eventually we had to remove the lead. So we replaced it with this stuff, MTBE, and it's produced in massive quantities to be used as a fuel additive. And again, part of the reason was to boost the octane level. There is, according to the Clean Air Act, we have to have a certain octane level in our gas to ensure complete combustion. The more oxygen is in something, the better it burns, so you don't get the particulate offput, you don't get the carbon monoxide offput into the atmosphere, so it's supposed to be healthier. But then we found out that the stuff we're putting in there to ensure that this happens is also carcinogen and is incredibly deadly and toxic to us. So what else do we have? Nitrates from fertilizers. They enter the body, right, and they have a greater affinity for oxygen. And once it binds to the hemoglobin, you get oxygen. You become oxygen poor. So we end up having this thing called blue baby syndrome, and it's because they don't have enough oxygen in their system. So you don't see the red color, right, from oxygenated blood. You see blue. So they call it blue baby syndrome. Of course, arsenic, which comes from industrial, it's an industrial product, but also found naturally. So that sucks, right, Gabe?
Mm-hmm.
Yeah. So again, prevention versus cleanup, you can find this on page 545. Take a look at these. Moving on. Purifying drinking water, typical in developed countries, held in a reservoir to increase dissolved oxygen, which allows, right, the breakdown of any type of biodegradable waste. The bacteria need that oxygen, and it helps things settle out, right, and settle towards the bottom where they can be cleansed. Or we can, in developed country, we pump it to a treatment plant, and we'll get to more of this towards either the bottom of this section or the next section. And what happens at a sewage treatment plant? How do we deal with these wastes? Here's some kids drinking the Life Straw, right, that you guys saw in class, hopefully. So we have processing of sewer water. Orange County, California is one of the places here in the United States. And what I mean by that is not just processing of, like urine or anything like that, but they're taking sewage. When you flush your poop away, they're taking that water, treating it and cleansing it so well that they can then turn around and pump it back to your house as drinking water. That's what they do in Orange County. Most places, though, across the U.S. where they have this technology, they're not allowed to pump it directly back to you because there's that gross yuck factor. So they take it instead, and this is super clean drinkable water, and they pump it out to the natural environment, where then it instantaneously becomes more polluted. But people like to know that it's passed through the Earth's cleansing systems before it goes to your tap, so you're more apt to drink it. If you don't have that, and you're in a third world country, you find yourself trapped somewhere, you take water, put it in a clear plastic bottle, expose it to the sunlight for a minimum of 3 hours. The UV light will kill hopefully enough of the organisms swimming around in there to then make it potable. And these guys have the carbon filter Life Straws. Beautiful. Okay, so Clean Water Act of 1972. We have to be familiar with what these things do. The Clean Water Act regulates the discharges of pollutants into the waterway, obviously meaning from industry, okay? So they're given a certain number of permits based on what chemicals they use, how big they are, and how much they have to discharge. They're allowed a certain amount of discharges into a water body, okay, or a river. The Safe Drinking Water Act 1974 establishes maximum contaminant levels for any pollutants with adverse effects on humans in our drinking water. Okay, that's a mouthful. So the U.S. Safe Drinking Water Act deals specifically with what we are drinking, what comes into our tap. The Clean Water Act deals with what can get discharged into the waterway. Okay? National Resource Defense Council pushing for a ban on a law that still allows today 10% of any faucet fixture in your shower, at your sink, to still be comprised of lead, which we know is a neurotoxin and is not good for us, but still, because industry lobbied for it, because it's an easy metal to work with, they have allowed them, even to today, 2015, to have lead. Up to 10% of that fixture can be lead. And that's what your water runs through that, and then you drink it. And that just seems stupid. Right, Gabe?
Right.
Stupid.
Very stupid.
Bottled water. Tap water in the U.S. is some of the cleanest water in the world, and it falls under the requirements of the Safe Drinking Water Act of the EPA. The EPA is a regulatory body that has teeth, meaning they can go out after people, they can take them to court, they can fine them, in some cases put people in jail. The FDA, however, has no authority at all, and bottled water falls under the FDA. The person who regulates all bottled water in the entire United States is one person, and that is one of the many jobs that this person has, meaning no one's looking at what's in your bottled water at all. I promise you that. U.S. consumption of bottled water has increased from 2 gallons per day in 1976 to 30 in 2006. The cost ranges from 240 times to 100,000 times more expensive than tap water. And 40% of bottled water contains fungus and or bacteria. Again, because nobody's looking at where this water comes from. You could go and drill a well in your backyard, name it the Mr. Pooler Bottling Company, and pump it into bottles and sell it. And what's worse is these plastic bottles end up all over the world. Again, that Pacific Ocean garbage patch. The number of plastic bottles thrown away each year could circle the Earth's equator 8 times if lined end to end. Toxic and greenhouse gases are released during the bottle production and transportation. Again, these are petroleum-based products, so when they're being manufactured, they're releasing CO2. Then we have to use petroleum-based products to transport them everywhere. On average, each bottle of Fiji water travels 5,500 miles before landing on a store shelf, and because it's incredibly expensive, ranges on the high side towards that number, 250 times more expensive to 100,000 times more expensive than tap water. This is on the high side. Oil used to produce the bottles consumed in the U.S. Would fill 100,000 cars with gas for a year. Whew! It's crazy. And that is the end of 20.3.
Good job, everyone.
Good job. Well done.